Robert must die free. Robert must die free. Go.
Welcome back to the morning show. It's 7:25 and it's Wise Guy Wednesday, but I got to tell you, I'm questioning the wisdom of the wise guy being out here. It is cold out here this morning.
Well, we did two silly things. We came out when it was really cold and we poured water on the ground to make it really slippery. So
mission accomplished there.
So this is how you make ice. Okay, very slippery stuff.
So in our first segment, you're talking about why ice is so slippery with that,
right.
that nanometers.
Very thin layer of water on there, even when it's below freezing. And so what we do when we get ice is we typically go and we get some salt and we... Now I'm fixing it so you guys don't have a lawsuit. And if you pour the salt out like this, okay, now you'll see, well, first of all, because the salt kind of gives you some friction,
right.
then you're not going to slip cut as easily. But also what happens is after a little while, it becomes slushy and the ice is basically melted. Mm-hmm. And so a lot of people have a misconception that somehow there's heat coming out of the salt and it's causing the ice to melt, but that's not what happens at all. What really happens is when salt mixes with water, it lowers the freezing point significantly, so that it's actually much harder for the water to freeze when it has salt mixed into it.
Okay. And this is actually then mixing with that very thin layer of water that's on top of the ice initially.
Exactly. Okay. And so here we have some slush. It's basically crushed ice with some water in it, and it's kind of soupy. And if you see the thermometer there, it's just above zero. It should be very close to zero. And if we dump a bunch of salt in here, and then we mix it together, I would use my hand. Okay, I will use my hand. It's very cold. Oh my gosh, that's cold.
Stick your fingers together.
Okay, now what you'll notice is that the temperature will start to drop of this mixture. Okay, and so you can actually get this to about 10 or 15 below zero.
Here, I'll pitch in.
Yeah, you can pitch in. All right. Okay. All right. I think the thermometer must be frozen. Anyways, so this is how you make ice cream, right? You take crushed ice and you pour a bunch of...
If we look at the stuff that you sprinkled on the ice just a second ago, that's already beginning to melt.
It's starting to kind of soak into the ice.
So then what happens?
On hold. That's the problem.
Oh. So what happens then after we lower the freezing point of that water on top of the ice?
Right.
Then that melts the water below.
Right. So what has to happen is it takes heat in order for ice to melt.
Right.
And that heat gets drawn from the surrounding water. It makes it colder. So basically, when you dump all that salt in there, in order for the water or the ice to become water, it has to suck the heat out of the environment, which makes all the rest of the slush a lot colder than it was. And you can see this thing starting to get colder now. Okay, I had the thermometer kind of not working right. So it's now at minus 6 degrees already. Celsius.
That's Celsius.
Right,
okay.
That's Celsius, minus 10.
So we use this regular off-the-store rock salt that you could use for making ice cream and stuff. A lot of the stuff that you buy that comes in the bag for sidewalks is more of a chemical mixture. Now, is that just a difference in where it's lowering the freezing point too?
It works exactly the same way. And so basically all it does is it disrupts the water's ability to form ice, to freeze. And so maybe it's just a cheaper way to make it.
So would rock salt, just regular salt be less damaging to sidewalks and things like that? Or?
I don't know what damages concrete, but this stuff is at least, you can eat it if you have some left over in the spring.
So clear the sidewalks and make some ice cream.
Right.
Okay, well, it's the wise guy telling us all the cold, hard facts, and trust me, they are cold facts about ice.
Minus 12 over there now, you'll see.
Neat. Okay, that's why salt works. We know why ice is slippery. Now we just got to get this out of here so nobody falls.
And I think next week we'll talk about driving on ice.
Next week, let's talk about furnaces and how they work to keep us warm or something. Okay, driving on ice. That's fine. If you got a question for the wise guy, you can email him directly, or you can link to his website from ours, wcia.com. Jennifer?